from a family of stonemasons and farmers in Cyprus. My first job on construction site with Grandpa the stonemason was collecting all discarded building materials, nails and heavy stones, and storing them for reuse. I started this project when I was in architecture school with Grandpa, and it took about 10 years to complete it because I could only work on it during the summer months. When I told my wife I hope to buy this house in Cyprus, and I showed her some of the pictures, and similar to this, she said, "We don't call this house in America, we call it ruins." But I think she is happy with the end result. When I look back now, I feel very fortunate growing up with these ethics of reduce, reuse, and recycle, and I carry them into my architecture practice today. As an architecture student in Istanbul, we didn't have architecture school in Cyprus when I was growing up, so I had to go to Turkey to study architecture. But being in Istanbul and studying architecture broadened this perspective of reduce, recycle, and reuse. And being surrounded with the Asian city actually galvanized these ethics further into my architecture career. Later in architecture school in the US, I met like-minded mentors, Dan Rockhill in Lawrence, Kansas, and Barry Langford in Albuquerque, New Mexico. They held similar commitment to sustainability as an ideology and not just as a set of practices. They also shared respect towards natural and reclaimed materials. This shows us quarrying stone for one of the historic preservation jobs in Kansas and cutting it and dressing it by using hand tools. I work with Dan as a stonemason on historic preservation jobs and on design build project as a carpenter and a welder. In New Mexico, I work with Barry on design build projects as a designer and a mason and a welder again. This is a residential project that was built with very thick masonry walls to reduce the sound of the very busy street. Following the trajectory of my wife's academic career as a disability studies scholar, we moved from Kansas to New Mexico, then to Rochester, New York. After a short stint in a small architectural firms, my partner Rick Hauser and I formed Inside Architecture. We built our practice on a mandate to incorporate sustainable principles into design process and produce integrated and environmentally innovative architecture. We renovated a turn-of-the-century masonry building in the village of Perry, south of Rochester, for our offices, and we set it as an open studio to enhance interaction and learning. One of our recent residential projects, we strive for reducing the carbon footprint to the levels targeted by architecture2030.org. And our office pledged to the targets, reducing the energy consumption beyond 50% set by this organization. After addressing the site characteristics of this project and studying the optimal solar orientation, we reduced the carbon footprint further by reusing slate chalkboards from an elementary school as countertops for the whole house, as well as the surround for the fireplace. We used concrete floors with hydronic heat in them, with very high efficient boiler, very high efficient wood stove with blower, high efficient LED lightings, and soy-based spray foam for air tightness. We used reclaimed beam from an old building as a stair rail for our stair. We also saved and reused most of the brick. We still have some. If you need some bricks, I have tons of them. For a village sidewalk to the house. We saved all the hardwood floor and reused throughout the whole house. When we were taking the walls and the deck down, we saved all the lumber and we reused them and incorporated them into the actual design and the construction. We also pulled every single nail out of these lumber, saved them along with the other metals that we took from the old house and sent it for recycling. The bottom left image is locally harvested larch and sawmilled, and they're ready to be installed on the old part of the house. We also planted a green roof on the part of the house, and these are mostly sedums and alpines. They're very hardy for our region. And what it does is it aids elimination of the cooling system in the summer months, as well as creating a micro habitat for butterflies, birds, and animals alike, and reduces the water that goes into the storm system. Another project with the low carbon footprint that we're working on is the research center and residence hall in Ranomafana National Park in Madagascar. Through a happy coincidence, we met Dr. Patricia Wright, a native Western New York and world-renowned primatologist, and who studies lemurs and biodiversity in the rainforest of Madagascar for the last 25 years. Her brother, Ted Chappell, a contractor from Avon, New York, bid on one of our projects, and he was very impressed with our mandate towards sustainability. And when Pat was looking for an architect for the new research center, we received a call from Ted. For this project, we focused on reducing the energy consumption and natural resources. We are providing healthy interior and outdoor environments by use of natural materials, and we're using local labor and local materials. The building is fitted in between the existing buildings, and on the right actually is the river. It's not shown in this picture, but right after those trees is a gorge down to the river, and the other side is the national park, without removing any vegetation. So we had limited area to fit this building, and this is the rendering fitted into that side. The footbridge bisects the building's entryway set against the Ranomafana National Park. Actually, this is the view that you're going to see as you come from the bridge through the entryway, as well as from all the spaces, the outdoor verandas and balconies. You're going to be able to be part of the rainforest, except this construction shed, so that will be gone. And this part of the rainforest, actually, Pat calls this Lemur Highway. So there will be lemurs actually just jumping along at that part of the forest. We used solar hot water panels for providing hot water needs for the whole building. And gray water system collects all the rain water through the roof drains into the cistern for reuse in the toilets. The 3-story atrium floods the space with natural light and acts as a natural chimney for ventilation and cooling in summer months. Green roof with local grasses will create a microhabitat and provide natural cooling and storm management. When I was taking this picture, Pat said, you know, you have to just get the scale, so use something for the scale, so I had to use a watch. So you can see how big that moth is. Another thing that we're using on this building is the thick granite and brick walls. This slide actually shows 2 brick kilns. One on the left is still burning, and the one on the right is ready to be pulled down and reused on the construction. These bricks are made right by the rice paddies, and it's from when they re-terrace the paddies, they use the extra clay to make them. So as you drive along the countryside, you see these brick kilns just burning, and the villagers selling the brick alongside of the road. The top image shows the entryway to the botanical gardens and zoo in Antananarivo, Madagascar, which is the capital of Madagascar. And when Rick and I was in Madagascar and we were driving around, we saw this granite wall, and we said we'd like to have this granite pattern and texture for the building. So our stonemason, Razu, on the bottom left-hand side, is doing a mock-up for us for that granite wall. For the interior finishes, for the walls, we're using lime and sand plaster mix, so it's a natural finish. For the floors, we are harvesting local bamboo and manufactured actually in Madagascar, and that will be the floor system. For the ceilings, we're again using local bamboo and making them into panels, woven panels done by locals, and using them as a ceiling system. This is a typical Malagasy village with a central common area. And this actually inspired us, and it was a concept for our residence hall level for the building. And this is a rendering showing the residence hall level of the rooms around the common area. We are also training local workforce for providing skilled labor as well as building materials. Top left image shows the building's foundation fitted in between the existing buildings and the river on the right-hand side. The top right image shows workers digging to the foundation about 3.5 meters, only using chisels and hammers and shovels. They stored all the stone from the dig, and then we're reusing them for the foundation. The top two image is the co-op formed by Pat through the research center as an outreach program. And this women co-op is going to provide all our bedspreads for the residence hall. The loom on the right top corner image is actually donated by Rochester Seneca Zoo. And bottom two image shows villagers making gravel out of discarded granite pieces that are going to be used for the building because there are no gravel quarries. So villagers are making them by sledgehammers. And trucks go by, and contractors buy them actually by buckets full. And this is the current status of the construction. We're right above the laboratory levels, and this is the ground level. This building will bring all the local community, scientists, researchers, and students, and together it will be a sustainable building. Thank you.